Alright, two of you, any questions? Methods, sorts. Can you remember the order of the 10 methods? You can try reciting. Yeah, go on. Zinc. Next. Iron, okay. Lead, good.
Hydrogen,
good.
copper, silver, gold.
Okay. 10 metals plus 1 hydrogen. Okay, good. At least you can remember that. Now, for you guys, you're interested in 3 types of reactions for metals. What are the 3 reactions for metals? Metal plus cold water and
Plastic.
okay, one at a time. Cold water, what do you get? Okay. How about you, Katin? Metal plus steam, what do you get?
Salt plus H2.
Salt plus H2. What kind of salt do you get?
Metal hydroxide.
Right.
Metal hydroxide.
Oh, okay, seems like you're not very sure. But at least the front part is correct. What's the last reaction?
Metal plus hydrochloric acid.
And what do you get?
Salt plus H2.
Okay, guys, let's be very clear. I mean, these are things that we have. Metal plus? Anyway, I'll just show you in case you've forgotten all these things. Okay, come guys, yeah, of course, totally right. These are your 3 reactions. Okay, these are your 3 reactions. Oh, okay, I tell you, sit here today. I think the girl is not coming. Okay, these are the 3 reactions which you ought to know. So, yeah, only 3 for your secondary school. 1, 2, and 3. Let me stress, for cold water you get hydroxide. And by the way, Kati, metal hydroxide is not a salt. Okay, hydroxide is not a salt. If you react with steam, you get oxide, not hydroxide. Can I please take note too? I think lastly, all of you should be familiar with the acid reaction with metal by now. It's only the first 2 that you may not see so often. But I can bet you the last one will come out. Yeah, so just take note, hydroxide, oxide, and salt. Reminder, in all 3 cases is H2, H2, and H2. That hopefully makes it easier to remember. Okay, so yeah, these 3 reactions for metals. Yeah, that's all. Only 3. Only 3. With the exception of displacement reactions, which I don't think I'll touch today. Oh, I'll just quickly go scroll through first, because I'm going to ask you all this again. And you're expected to write the reaction. Oh, Xingyue, I was asking them, The 10 metals you need to remember. Are you able to remember the 10? The 10 metals in order. No, okay. Can go back and remember. Neil, can you remember the 10 metals in order? Go back and read through. I'll ask you next week. Okay, anyway, guys, I just want to highlight some special things. Look at this one. Magnesium plus water. Yes, nothing strange. Magnesium hydroxide. But I want you guys to take note. This is a solid. Magnesium hydroxide is not soluble in water, so that's why it's a solid. Okay? This is a special case. Oh, by the way, in case you didn't notice, after magnesium, no more reaction already. So, good news. How I remember is, for the first one, metal plus cold water, only the first four. 1, 2, 3, 4. Alright, only the first four. You have a reaction. Then after zinc, good news. There's no reaction at all. So no need to remember anything. But steam is more reactive than water. I hope you guys can intuitively grasp that. 1, 2, 3, 4, 5, 6. For steam, the first 6 metals can react, up to iron. So up to you. Try to. Personally, I remember in this order: cold water, steam. Last one is acid. Right. So 4, 6, and 6. First 4 metals, first 6 metals, first 6 metals. 4, 6, 6. If you want to remember that. Now, of course, each of them has their own reaction, has their own equation. I will ask you to write them down one of these days. Can you highlight this one special? Look at the oxide. What iron oxide is that?
Iron 3.
Iron 3, Is it iron 3?
3 plus.
3 plus? Is it 3 plus? This one? Calculate. Is it 3 plus? This is quite special. 2 plus? 3 plus. Come guys, this one is a bit of a funny thing that you have to note down. Maybe I just write down. Oh, sorry, I haven't. I just write on the whiteboard. This one is a very special iron oxide. It's called magnetite, even though I've never seen them asking for the name before, but you have to know the formula, Fe3O4. Now, what is special is it's a mixture. It's a mixture of iron 2 oxide and iron 3 oxide. As I said, it doesn't come out all the time, but it's still in your syllabus.
Move down.
Move on.
Move down.
Sorry, what did you say? Move up. Move up? Nothing already, no reaction. Okay, last one I want to highlight is this one. Now, what's so special? Is it iron 2 or iron 3?
Iron 2.
Okay, this is iron 2 chloride, iron 2 plus. So take note, your answer should be iron 2 chloride. Oh, in case you want to ask why, this is the reason. Even though you do not need to know it. Okay, you won't be asked this, but just remember that you get iron 2 chloride rather than iron 3 chloride. So these are the small things that I want to highlight to you. And guys, you're supposed to remember your solubility rules. Iron oxide is insoluble in water, so that's why it's a solid. You're supposed to remember that. Likewise here, this is very special. May or may not come up. It forms lead 2 chloride, and you're supposed to remember lead chloride is insoluble. Just a short one. Super short. You won't see anything at all. Maybe some bubbles and then that's it. Okay, that's why if your year is difficult, they may ask you this: how come there's no reaction? Remember, lead is above hydrogen, but yet lead doesn't show any apparent reaction. This is the reason. Okay, lead chloride is insoluble, it covers the lead, and then it basically stops the further reaction. Okay? Oh, I'm just revising with them about this matters part. Okay, we'll do this a more comprehensive review on another day for this part. But I just want to highlight some of the things that you want maybe take note of. Okay, questions? No? Oh, let me get your worksheet. Okay, let's go through a quick review of what we did last week. Remember, for rate of reaction, there are some factors that can affect the rate of a chemical reaction. Senior, give me one. Yes, temperature. How does it work? Temperature increases, rate. Okay, good. Oh, she's busy. Kati, give me another one. How does surface area work? Okay, but sometimes your question will not use surface area. Yes, powder, more or less surface area? Powder means more surface area, so reaction is faster. Venice, any other factors? Pressure, okay, how does pressure work? Higher the pressure. Okay, in general, higher the pressure, faster the reaction, provided you have a gaseous reactant. New, last one. Okay, how does it work?
The more concentrated,
Okay, right, guys. Temperature, surface area, pressure, and lastly, concentration.
How about the catalyst?
Oh, catalyst, how does catalyst work?
It's just a substance that's
Yeah, that's all. As long as you have a catalyst inside, then rate of reaction becomes faster. Yeah, that's all. Okay, now, again, perhaps this is what you have to always remember to write. Okay, basically, the faster the reaction, it implies your frequency of effective collision is higher. Frequency of effective collision is higher. Always write that phrase in for your answer. Can I? Let me see. Last one. Last thing. This is likely to come out also. They'll give you a graph. X-axis is always time. Y-axis could be volume of gas product. So, how's the curve going to look like? Increasing or decreasing? Why? Yes, it's a product. How do I know what's the rate of reaction based on the graph? How do I measure the rate of reaction based on the graph? This one may or may not come up, but it has come up before.
The steepest.
The rate of reaction is the
steepest.
I think you get the idea. Guys, that is important. It may or may not come up, like I said, but if your question asks you, determine the rate of reaction. Let's say, sometimes they will ask you like that, what's the rate at 1 minute? Oh, you may need to draw the graph. No, it's just like your max, you try to measure the gradient. I assume you are familiar with your max. Okay, that is the rate at 1 minute. But there's another question they can ask.
Next question. Explain in your own words why onshore was critical.
This has also come up before. They ask you what's the average rate between 0 and 1 minute. So how? What should you do? Yeah, see what should you do? Average rate.
And the two answer and divide by
Two answer where, right?
0 and 1 minute.
Okay, actually that will work. But I'll just give you, actually your answer will work. Good answer, but the other possibility is I take a point from 0, join to 1 minute point, and calculate the gradient. So that is my average gradient. I assume you're familiar with this in maths as well. Average gradient versus the point gradient. This is the average. This is gradient at the point reference event. Last thing, watch out for the units.
Whole sentence. Okay. Read the question. Explain your own words.
Now, your rate has units, in case you probably haven't figured it out. But what for this example, what are the units for my rate?
Minute per DMC.
Minute per DMQ. My gradient is, I mean, in your geography, they'll say rise over run. So it's always, I hope you know your maths. Y over x, y over x. What is y? DMQ. What is x? Minute. So your unit will be
Can be found inside or creation. You can just those which you can't really replace. Then
I mean, it may be a small thing, but try not to miss out the units for the gradient. The gradient has units. Y over x. Y is dm cube. X is minute, so dm cube per minute. Let me see, anything else I need to tell you? Yep. Okay. As I said, rate of fraction is a simple chapter. Try to score for that. Okay. I got a couple of open-ended questions for you. But before you start, maybe I'll just give you a few hints about a few questions. Unless you think you're really good at it. Okay, where will we? Here. Okay, first thing first. Hydrogen peroxide. Somebody tell me, what is it? What's the formula? Anybody know? No? Okay, guys, write down your notebook. This has come up many times in the past. Even though your school may not mention it much. It looks like water, but it's not water, so do not be mistaken. You have to know it. It has come up almost every year. Maybe not with this question, but another kind of question. Maybe this. At room temperature, it's a colorless liquid, right? Just like water. But what is important is it can break down. It can break down into water and O2. And oh, by the way, it has come up for practical exam quite a few times. Therefore, what will you observe? You will observe bubbles. It has come up many times in practical actually. Question, Anybody can remember? What type of reaction is this? Remember, we have gone through a few types of reaction. What kind of reaction is it? Precipitation, neutralization, oxidation. Okay, half correct. But we haven't done oxidation yet, so I won't mention that. But we'll mention something else. Hey guys, better take note. This is called
Decomposition.
one reactant becomes two or more products. That is a decomposition reaction. Sorry, and have you seen this before? This is decomposition. Oh no, metal rectangle. I mean, I've gone through this with them before. One question, do I need to heat it for this to occur? Answer, oh, I answer for you. Answer is no. That means if I have a hydrogen peroxide here, it will automatically decompose. I don't need to heat it. So there is no thermal. I do not need to write the word thermal in front because I don't need to heat it. But on the other hand, if I have thermal decomposition, it's still the same. One reactant gives you two or more products. Yeah, nothing there. Except I need repeated reactants. So that is the difference between thermal decomposition and decomposition. And the best example, which you all of you have to know, is somebody